Cobalt chloride is an inorganic compound of cobalt and chlorine, with the formula CoCl2. It is usually supplied as the hexahydrate CoCl26H2O, which is one of the most commonly used cobalt compounds in the lab. The hexahydrate is deep purple in color, whereas the anhydrous form is sky blue. A blend would be mauve. Because of the ease of the hydration-dehydration reaction, and the resulting color change, cobalt chloride is used as an indicator for water in desiccants. Niche uses of cobalt chloride include its role in organic synthesis and electroplating objects with cobalt metal. Cobalt chloride has been classified as a substance of very high concern by the European Chemicals Agency as it is a suspected carcinogen. Properties: aqueous solutions of both CoCl2 and the hydrate contain the species Co6(2+). They also contain chloride ions. In the solid state, CoCl26H2O consists of the molecule trans CoCl24 and two molecules of water of crystallization. This species dissolves readily in water and alcohol. Concentrated aqueous solutions are red at room temperature but become blue when heated. CoCl26H2O is deliquescent and the anhydrous salt CoCl2 is hygroscopic, readily converting to the hydrate. Preparation: hydrated cobalt chloride is prepared from cobalt hydroxide or cobalt carbonate and hydrochloric acid. Co2+2 hydrogen chloride Co6Cl2. Upon heating, the hexahydrate dehydrates in a stepwise manner. An aqueous solution of CoCl2 on addition of excess of concentrated hydrogen chloride gives CoCl4, which is detected by blue coloration. Reactions: generally, aqueous solutions of cobalt chlorides behave like other cobalt salts since these solutions consist of the Co6(2+) ion regardless of the anion. Such solutions give a precipitate of Cos upon treatment with H2S. CoCl26H2O and CoCl2 are weak Lewis acids that react to give adducts that are usually either octahedral or tetrahedral. With pyridine, one obtains the octahedral complex CoCl26H2O plus 4C5H5N CoCl24 plus 6H2O with the bulky ligand triphenyl phosphine 3 tetrahedral complexes result. CoCl26H2O plus 2P3 CoCl2 P3 2 plus 6H2O. The anionic complex CoCl42 minus CoCl2 plus 2 4N Cl 4N 2 CoCl4. The CoCl4 2- ion is the blue ion that forms upon addition of hydrochloric acid to aqueous solutions of hydrated cobalt chloride, which are pink. In the laboratory, cobalt chloride serves as a common precursor to other cobalt compounds. Reaction of the anhydrous compound with sodium cyclopentadienide gives cobaltocene. This 19-electron species is a good reducing agent, being readily oxidized to the yellow 18-electron cobaltocenium cation. Reaction of 1-organolithium with the CoCl2 THF in pentane produces the brown, thermally stable cobalt tetralkyl, a rare example of a stable transition metal, saturated alkane compound. Different products are obtained in other solvents. Co-derivatives: in the presence of ammonia or amines, cobalt is readily oxidized by atmospheric oxygen to give a variety of cobalt complexes. For example, the presence of ammonia triggers the oxidation of cobalt chloride to hexamina cobalt chloride. 4CoCl26H2O plus 4NH4Cl plus 20NH3 plus O24 Co6Cl3 plus 26H2O. The reaction is often performed in the presence of charcoal as a catalyst, or hydrogen peroxide is employed in place of air. Other highly basic ligands including carbonate, acetylacetonate, and oxalate induce the formation of co-derivatives. Simple carboxylates and halides do not. Unlike co-complexes are very slow to exchange ligands, so they are said to be kinetically inert. The German chemist Alfred Werner was awarded the Nobel Prize in 1913 for his studies on a series of these cobalt compounds, work that led to an understanding of the structures of such coordination compounds. Instability of COCl3. The existence of cobalt chloride (COCl3) is disputed, although this compound is listed in some compendia. According to Greenwood and Earnshaw, the only stable binary compounds of cobalt and the halogens, excluding COF3, are the dihalides. Stated differently, COCl2 is unreactive towards Cl2. The stability of Coin solution is considerably increased in the presence of ligands of greater Lewis specificity than chloride, such as amines. Safety. In 2005-06, cobalt chloride was the 8th most prevalent allergen in patch tests. In popular culture, the NZ National Film Unit Pictorial Parade No. 23 features cobalt chloride as the missing component in the pumicelands near Rotorua. Without this compound, no cattle would be able to survive on this land, only wild horses. Other uses. Invisible ink. Cobalt chloride is an established chemical inducer of hypoxia-like responses such as erythropoiesis. Cobalt supplementation is not banned and therefore would not be detected by current anti-doping testing. Cobalt chloride is a banned substance under the Australian Thoroughbred Racing